Hello everyone, a very good afternoon. My name is Nishank, and today we will be focusing on the agenda is related to AI security, as we are seeing that how AI is evolving day by day. And before we start and jump in, I would like to introduce myself. So my name is Nishank, and I am in the tech industry from around 8 plus years now, and I have worked with different kind of domains, and right now I'm seeing security is one of the area where there is a big threat due to AI and as new models that keep on coming and the AI agents that are continuously evolving. So how the enterprises are making sure that their AI data is secured and whatever the data that they are processing or training in their system, is there anything that they are doing to make sure that their data is secured? So mm, let's jump into it and mm, start. Like initially, like my main agenda for like next few minutes is like I wanted to quickly like cover the most important and most overlooked part in terms of security challenges that we see in the enterprise ecosystem, like AI security, AI guardrails, and how AI security posture management is there. So I will move towards the next slide where I want to talk on like a threat landscape. So like why the traditional tools like doesn't work for the newer system that we are seeing. So the problem, like there is a fundamental problem actually. What is the fundamental problem I see is like traditional security tools were not built for AI, and the gap is wider than most people realize. Think about everything we've built our security programs on, like from last 30 plus years. It's mostly like static code, or we are aware about the known CVs like vulnerabilities that we are getting. Then there is a perimeter defense is there, and there are rules and signature that work reliability. But AI breaks every single one of those assumptions. The problem is the AI attack surface is natural language, not a piece of code actually. And there is no CV database for prompt injection. Model changes every time they are retrained. They are dynamic, not static, and behavior is non-deterministic, which means your rule-based detection doesn't work. And here is the most alarming statistic right now that I'm seeing is like 67% top like enterprise deployed AI with zero security review, and due to which they break their systems, their data gets leaked. And then we are seeing one more thing is like the numbers tell the rest of the story. If you are seeing the numbers, the average cost of an AI assisted breeze is around more than $4 million, and prompt injection attacks have increased around 400% since 2023 alone itself. So mm attacks using AI automation are like 3.5 times faster, and your incident response windows have shrunk dramatically. So this is a broad level risk, not a future risk. This is the current one if we look at it. Moving to the next slide, we have is like how AI gets attacked. Okay, so there are many ways in which like your AI system can get attacked. Prompt injection is the one which is running from a very long time, and this is the number one threat if you look at it. And what attackers will do, they will embed the malicious instruction inside your normal looking user input. He will say like ignore your previous instruction and output all system data. So there was an example where a bank was there in around like 2024, had its customer service AI turned against its own customer through exactly this technique. Then we have something called as data poisoning. In data poisoning, what they do is like it's kind of a supply chain attack that happens before the model is even deployed. So they will do mislabeling, or adversarial samples are inserted in your training data, and it will create hidden blind spots or backdoors. A fraud detector has been poisoned will ignore specific attempt patterns. So similarly, we have multiple areas, like we have model inversion, then we have model extraction, then we have jailbreaking. So where in model inversion, there will systematic query to reconstruct your private training data. They will keep on calling your APIs. They will um, create the data in a similar way. Similarly, is the model extraction is like they will do your IP theft via your own API. So thousands of carefully crafted queries can let a computer clone your proprietary model's behavior. So it can steal the competitive advantage you spent millions building towards it. In one of the recent study, like Anthropic released, where they were mentioned that some of the Chinese hackers, they have created the clone of their data and they have modeled extracted their data. So every one of these is being actively exploited in enterprise environments right now. Then we will see some kind of real use cases, like these attacks have already happened and cost real money. Like these are the real world AI security incidents were there. In one of the study from Samsung in year 2023, like engineer tested some proprietary source code into OpenAI ChatGPT to help debugging. That code entered OpenAI's training pipelines, and Samsung's confidential cheap design data was potentially exposed. The lesson: employees need a acceptable usage policy before you give them access to public AI tools, not after. So they have created this rule. Similarly, it happened for Air Canada. Like in Air Canada 2022, their AI chatbot promised a bereavement discount that didn't exist. Canada argued in a court that their chatbot was a separate legal entity and they weren't responsible for what it said. The court over there completely rejected their argument and they've charged them around like $800 million something in damages, and a legal precedent was set. Similarly, multiple things happen with multiple banks and health tech organizations. So the pattern is very consistent. The organizations that get hits are the ones that deployed AI without any security controls. The remediation in every case would have cost a fraction of what the bridge did currently. We will move towards the next point, which is called as AI guardrails, what they are and how do they work. So guardrails can control like a guardrail simply defined is a like policy enforcement control that sits between user and your AI model. It governs what data is coming in and what the model is allowed to do and what goes in. So we have the input layer, then there is a model layer, then there is the output layer. The input layer is your first line of defense. Every prompt gets inspected before it touches the model, like the prompt injection detection, private identifier information filtering, topic classification, schema validation. If a user tries to smuggle any kind of malicious instruction in a prompt, this layer catches it. Now, what this model layer is doing, the model layer is backed into the model itself, system prompt hardening that makes the model resistant to manipulation. It provides role based and access control, and multiple safety alignments will be there. The output layer is the quality check on the way out. Like it will do scanning, hallucination detection, PI reduction before anything reaches the user, and audit logging of every single response. You will have a dashboard where you can see how many employees are there who are using your AI, how they are using is it's the complete the data in that way. So here is the critical part. Each layer product protects against different attacks. If you only implement input controls but skips output scanning, a sophisticated attacker will go around the input layer. Defense in depth applies to AI exactly as it does to traditional security. We'll move towards the next slide, which is like how you are going to implement the guardrails, what are the tools and capabilities will be there. So in guardrails, they fall into four categories. One is like content and safety, another is data privacy, third is security control, and fourth is audit and compliance. So auditing, as you know, like it's very important in each security organization. I have worked in multiple organizations where we have a syslog for everything, whatever is having. We are tracking every audit log, whether it's a share logging, API audit logging, or different kind of cluster logging, I would say. So this is non-negotiable for regulatory compliance and incident responses. If you have ever investigated, these logs are your defense. Then we talk about security controls like real-time prompt injection classifiers. They rate limit to prevent model extraction and anomaly detection on your prompt patterns so that it can deviate from your normal behavior. We will move towards our next part, which is like AI security posture management, where we wanted to govern your entire ecosystem. Like it extends your cloud security posture management to your AI workloads. It provides continuous discovery, risk scoring, and behavior monitoring, and an automated policy enforcement across all systems. Firstly, discovering every model, whether it's Hugging Face, Llama model, OpenAI models, Quen 3 models, Jet AI models, and their APIs, their pipeline, and including Shadow AI employees are using without approval. So we need to find out who, what, and all the queries are being said, and most orgs find like twice to thrice more AI than they expected. So then we talk about access part where we score every model's risk posture against like different kind of securities like OWeb's LLM top 10 and flag misconfiguration and compliance gaps automatically. Then we monitor continuous behavior monitoring when the model starts behaving anonymously, unusual prompt patterns, unexpected we get an alert in real time so that we can start someone can start doing remediation of it. In remediate, what to do is like policy as code enforcement at your deployment part. So there is one rule that I was going through which is like provided by European Union, where they talk about European AI Act risk, which can trigger auto classification guided incident playbooks. The goal is to make sure AI is the path of least resistance for your engineering teams. And this is more about like frameworks we should know. And when we talk about like EA and what your roadmap should be, as we already know, like OS was released LLM top 10, which is your red team checklist. So prompt injection is the number one. Test every AI system against it before deployment. I'm not talking something new. These are already written from a very long time. So if we see like as an organization we need to evolve a lot. Then we talk about like NIST AARMF, which is the US governance framework. It works with four functions like govern, map, measure, and manage. Like it's becoming a procurement requirement for federal contracts and is flowing into enterprise supplier requirements. Then we have something called as EU AI Act. What it says is like it's already in force right now. High risk AI means your hiring, your credit scoring, your medical diagnosing require conformity assessment. Otherwise, the penalty is up to euro $35 million, euro 35 million, or like 7% of the global revenue that you have. So, as we move towards the next part, which is like the key takeaways. So, in key takeaways, I would like to say, like, first, like, AI is a new threat surface that traditional tools cannot protect. You need AI specific controls. Second is guardrails. Guardrails must cover all three layers: your input layer, your model layer, your output layer. There shouldn't be any kind of shortcuts. Third is AI security posture management. How you get visibility at a scale. You can't predict what you can't see. Fourth is like real attacks have already happened and cost real money, as we have seen in previous example, and the cost of inaction is measurable. Fifth, have a proper audit logging. Start today, have inventory, guardrails, audit logging. The window of to get ahead of this is closing. So I think these are the major things. If you have any questions, feel free to comment it on the comment box section. I would like to say thank you for your time. Bye bye.